Hi students, today we are going to start a new module in our paper Nanoscience and Technology. The name of this module is Growth Techniques of Nanomaterials. In this module, we are going to discuss about the various synthesis techniques which are used to fabricate nanomaterials or which are used for the growth of nanomaterials. അപ്പോൾ നാനോ മെറ്റീരിയൽസ് ഉണ്ടാക്കാനുള്ള വ്യത്യസ്ത സിന്തസിസ് ടെക്നിക്കുകളാണ് ഈ മൊഡ്യൂളിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോണത്. So before we go into the actual synthesis technique, we will discuss here the two approaches which are followed for nanomaterial fabrication. One is the top-down approach and the other one is the bottom-up approach. എല്ലാ നാനോമെറ്റീരിയൽ സിന്തസിസ് ടെക്നിക്കുകളും ഈ രണ്ട് അപ്രോച്ചുകളിൽ ഏതെങ്കിലും ഒന്നായി ക്ലാസിഫൈ ചെയ്യാവുന്നതാണ്. ദി ഡിഫറെൻറ്റ് സിന്തസിസ് ടെക്നിക്സ് ദാറ്റ് യു യൂസ് ടു ഫാബ്രിക്കേറ്റ് നാനോമെറ്റീരിയൽസ് ക്യാൻ ബി ഗ്രൂപ്ഡ് അണ്ടർ any one of these approaches. Now, what is the top-down technique or top-down approach? Here, we take a bulk material and it is sliced down or cut or we grind it to get nanomaterials. Okay, so that the bulk material is reduced to the size of a nanomaterial and we get the product. So here a bulk material is taken and machined, that is sliced or cut so that it is modified into the desired shape and we get the product in nano size. In nanomaterial synthesis, ball milling is an important top-down approach. So ball milling is the example of a top-down approach synthesis technique. A top-down synthesis technique is ball milling. That is, here you take the precursors of the nanomaterial in their bulk form. The precursor means the reactants which are used for synthesizing the desired nanomaterial. The reactants are taken or the precursors are taken in their bulk form and these precursors are then grinded or it is ground using different steel balls having various shapes, having various sizes and masses. So the precursor material is ground using steel balls having various sizes and masses. In the process, what happens is the precursor material gets broken down into nano-sized particles or you get the nanomaterial. Now, lithographic technique is another example of a top-down approach. Lithography we'll be discussing later. Next, what is bottom-up approach? It is the opposite of the top-down approach. In top-down approach, we take the bulk material and break it down to nanoscale. Whereas here, we take the basic materials and then build up the nanomaterial. Basic material means we are assembling atom by atom or molecule by molecule and we get the nanomaterial. So, in this approach, the nanomaterial is built up from the basic materials. That is, assembling of atoms or molecules is done to form the nanomaterial. Here, the self-assembly of atoms or molecules are obtained, which in turn forms a self-assembled monolayer. Examples of bottom-up approach are chemical vapor deposition, physical vapor deposition, sol gel technology, epitaxial growth, electrodeposition, etc. So these are the two basic approaches which are followed. Either you take the bulk material and break it down into nanomaterials or the atoms or molecules assemble together and reaches the nano size. So these are the two approaches followed. Next, what we discuss is the actual nanomaterial synthesis technique. So nanomaterial synthesis techniques are classified into two. One is the lithographic technique and the other one is the non-lithographic technique. Now, what is meant by lithographic technique or lithography? It is a printing method that uses chemical processes to create an image, or you take a semiconductor surface and on that an image is printed, and this method is called lithography. Now, lithography actually it's a Greek word. Litho means stone, graphy means writing or printing and all. So you're printing using stones. So how can we print using stone? Now the picture to be printed is carved on the surface of the stone. നമുക്ക് പ്രിൻ്റ് ചെയ്യേണ്ട പിക്ചറിനെ സ്റ്റോണിൻ്റെ മുകളിൽ കൊത്തിവെക്കുക, കല്ലിൻ്റെ മുകളിൽ കൊത്തിവെക്കുക. ആൻഡ് ദെൻ ദ സ്റ്റോൺ വിത്ത് ദിസ് കാർവ്ഡ് ഇമേജ് ഇസ് ഡിപ്ഡ് ഇൻ ഇങ്ക്. അതിനെ ഇങ്കിൽ മുക്കുക. ദെൻ ദ സ്റ്റോൺ which has the carved image on it, which now has been dipped in ink, can be pressed on any particular surface where the image is recreated. So a similar technique is used in lithographic fabrication of nano materials or nano devices. What is done here is the image is printed on a silicon wafer or any other semiconductor wafer surface. So types of lithographic process. Lithographic process is divided into two: photolithography and electron beam lithography. First, let us discuss what is photolithography. Here, light is used to transfer a geometric pattern from a photo mask to a light sensitive chemical called the photoresist on a substrate. So initially we have a substrate. We have a substrate on which we coat, say, a silicon wafer on which the image has to be printed. On top of it, again, one more material is coated, that is the photoresist. On the surface of the silicon wafer, you coat the photoresist. What is photoresist? It is a light sensitive chemical. Now, we have a substrate, the wafer on which the silicon wafer on which the image has to be printed, and on top of that the photoresist. Now we take the light source. Now the light from the light source is allowed to pass through something called the photo mask. So what is a photo mask? It allows light only to pass through certain areas and blocks light in the other areas. So this is the example of a photo mask. Light passes only through all these openings so that you get the desired image here on the surface of the substrate. Now the light passes through the photo mask, and the regions where the light touches the surface of the photoresist, that is on the substrate. Now we have coated a material called photoresist which is sensitive to light, and those regions which are exposed to light after the light passes through the photoresist and falls on this the light passes through the photo mask and reaches the photoresist, and those regions which are exposed to light undergoes a chemical reaction. Now the next process is to develop this photoresist. That is, you wash this photoresist surface with some suitable solvent. In a positive photoresist, the exposed regions get washed off. Whereas in a negative photoresist, when you wash it with suitable solvents, the unexposed region gets washed off. Now, depending on the type of image that you need to grow on the surface or need to develop on the surface of the film. After this process, we follow techniques like etching or lift off so that you get the desired images on the surface of the silicon wafer. So this is the photolithographic process. Here, light is used to transfer a geometric pattern from a photo mask to a light sensitive chemical, that is the photoresist on the substrate. Depending on the pattern on the photomask, various structures can be generated on the substrate, which is further used to develop different silicon-based photonic and electronic devices. Deep ultraviolet light with wavelengths 248 nanometer and 193 nanometer are used, which allows the fabrication of nanomaterials of size as small as 50 nanometer. This is photolithography, where where light is used to generate these images on the surface. The second technique, that is lithographic technique, that is followed is the electron beam lithography. Here electron beams are used to generate the pattern on the surface. Here we do not use a photomask. Instead, the electron beam is used to generate patterns on the surface. So it is used to make materials in the submicrometer regime, but the rate at which the electron beam generates the pattern is very slow. So this form of lithography is not much used in, it's not a standard technique which is used in industry because of the very small speed with which the electron beam generate patterns on the surface. So it has been found that this electron beam lithography is used predominantly for mask making, the photo mask that you used for photolithography. So electron beam lithography can be used for mask making and low volume production of semiconductor components. But both these lithographic techniques seems to be approaching their limit and are not of much use in fabricating zero-dimensional and one-dimensional nano structures. It's found that the maximum or the minimum size for the nano structures which can be developed using the lithographic techniques are nearly in the range of a few nanometers. But we require synthesis techniques which are capable of fabricating zero-dimensional and one-dimensional nanostructures, for which the lithographic techniques are incapable. So alternative non-lithographic techniques are developed. This here I have just shown you diagrammatically the electron beam lithographic technique, which you can go through. Now, what are the non-lithographic techniques? In non-lithographic technique, it is a natural self-organization process, and the non-lithographic techniques, so these are not printing techniques. Here, actual synthesis of the material by self-organization is of the nanomaterial by self-organization takes place. So these techniques are broadly divided into vacuum-based process and solution-based process. Now, what are vacuum-based process? Here the deposition takes place under high vacuum. So the process is very clean. Because other materials are not present, here the probability of contamination is nil, almost zero. It is highly favorable for device fabrication, but the disadvantage is that the technique is quite costly and complicated equipments like vacuum pumps, gauges, leak-proof accessories, etc. are required here. Examples of vacuum-based non-lithographic techniques are evaporation, sputtering, chemical vapor deposition, laser ablation, molecular beam epitaxy, plasma arc method, etc. Next, solution-based synthesis process. It is based on chemical reactions in the liquid phase. So these techniques are simple and cost-effective. Large range of nanomaterials can be synthesized by this method, but it's not a very clean process, unlike the vacuum-based non-lithographic synthesis technique, because here chemical reaction of the constituent precursor materials in the solution can result in so many products, out of which all of which will remain in this solution state, and it will affect the desired nanomaterial which is going to be synthesized. That is, here chemical reactions with the constituent materials in the solution take place, and many undecided molecules and ions can remain within the synthesized material, which affects the desired quality of my synthesized material. Also, solution-based techniques are not compatible with the solid-state manufacturing technology used for making electronic and photonic devices, because these methods are solution based, so it does not match with our normal, or it is not compatible with our normal solid state device manufacturing technology. Now, examples of solution based techniques are sol gel technology, electrodeposition, spray pyrolysis, spin coating, dip coating, etc. So, in today's class, we have discussed the two approaches which are used for nanomaterial synthesis. Next, we discussed the classification of the actual nanomaterial fabrication techniques into two, that is, lithographic techniques and non-lithographic techniques. Lithographic technique means it is a printing method where we use a chemical process to create an image. The two classifications of lithographic method are, one is the printing method that uses light, that is photolithographic method, and the other printing method which uses an electron beam, that is electron lithography. Electron beam lithography. Next, we discussed the non-lithographic methods, so which are certain self-organization processes. The two classifications of these non-lithographic techniques are vacuum-based techniques and solution-based techniques. In vacuum-based techniques, the synthesis process is taking place under high vacuum, that is under very, very low pressure. Examples are evaporation, sputtering, chemical vapor deposition, molecular beam epitaxy, etc. And in solution-based process, this involves the production of nanomaterials on the basis of chemical reactions in the liquid phase. So these are simple and cost effective, but they are not highly clean. So many undesirable molecules and ions may also get together with the synthesized material, which will affect their property. Also, solution-based techniques are not compatible with our solid state device manufacturing technology. So these are the disadvantages of solution-based non-lithographic synthesis techniques. The examples are sol gel technique, electrodeposition, spin coating, spray pyrolysis, dip coating, etc. So I hope this session is clear to all of you. If you have any doubts, please do contact. In our next session, we will be dealing with the non-lithographic techniques in detail. Thank you.